Dear students, now in this class we will discuss about the interior point of E. What is an interior point? Let X is any set, X be any set. So this is X. A is a part of this X. A is a subset of X. Then any point X following A is said to be an interior point of A if it is the center of some open sphere contained in A. That is, X is an interior point of A means this X being the center of an open sphere which contains in E. So there exists, and if X is an interior point of A, means this X be the center of an open sphere having radius some r, whatever may be, which contains in E. So, and the set of all interior points of E is known as interior of A. Interior of A is the set of all interior points of E. So clearly this interior A is a part of A. Interior of A is a part of A. Sure? Yes. Why? Interior of A is the set of all interior. What is interior A? Set of all interior points of A. So clearly, what interior point means, which is interior point of, means that point being the center of an open sphere which is contained in A. So clearly, interior A is a part of A. If A is open, what happens? If A is open, then clearly this interior A equals A itself. A is open if interior A is A. Why? We know that interior A is a part of A. Okay, that is marked as 1. Suppose A is open, then what happens here? Since A is open, there exists an open sphere which contains in A. That is SR of X is a part of A. There exists an open sphere having center X and radius R, means there exists an R positive, there exists R greater than 0 such that SRX is a part of A. SRX is a part of A means let X fall in E. A is open, and to prove that interior A equals A. We know that interior A is a part of A. Now to show A is interior A equals A, then it just remains to show that A is a part of interior A. Okay. So let X fall in A. Let X fall in A. Since A is open, then there exists R positive such that SRX is a part of A. SRX is a part of A means X is an X fallen interior A, or X is an interior point of A means X fallen interior A. X fallen interior A means, but X fallen A, clearly A is a part of interior A. So combines we have 1 and 2, then interior A equals E. So when A is open, then interior A is A. Interior A equals E. Agree. Now, interior A is also an open set. What is an open sphere? We already proved that an open sphere is an open set. Okay. Now here we try to show that interior of A, suppose A is a part of X, then interior of A, interior A is an open set. How to prove this interior A is an open set? To show interior A is an open set, there exists an open sphere which is nothing but a part of interior A. Okay. So for let X fall in interior A. X fall in interior A. X fall in interior A means, what is interior A? It is interior A is the set of all interior points of E. Interior A means it is the set of all interior points of A. So let X fall in interior A means X be an interior point. X be an interior point. X be an interior point of A. x be an interior point of A means, what is interior point? This x being the, when x be an interior point of A means x be the center of an open sphere which contained in A. So means there exists some R positive such that S Rx is a part of A. Okay, S Rx is a part of A. Now this one. Let Y fall in SRX. Let Y fall in SRX. What is SRX? SRX is an open sphere. We know that an open sphere is an open set. SRX is an open sphere. So clearly this SRX is an open set. Why? Because open sphere is an open set. Since SRX is open, there exists some R1 greater than 0 such that S R1Y is a part of SRX. Okay, why? Because SRX is open sphere is an open set. Then there exists some R1 is positive with SR1Y is a part of SRX. SRX has an open sphere. Agree? But what is SRX? SRX is a part of A. So clearly, since SRX is a part of E, we know that SR1Y is a part of A. SR1Y is a part of A means what is Y? Clearly, SR1Y is a part of A means Y be an interior point of A. Okay, Y be an interior point of A. Since Y be an interior point of A means Y is present in interior of A. Why? Because interior of A is the collection of all interior points of A. Since Y be an interior point of A, surely Y fall in interior A. But what is Y? Y is chosen from where? SRX. And Y is same Y fallen where? Interior A. That means Y fall in SRX and Y fall in interior A means SRX is a part of interior A. SRX is a part of interior A means interior A is open. That means interior A has an open sphere such that means interior A is open. So this is the proof. So interior A is always open. If A is a part of X, what is interior A? Point X is an interior of A if it being it is nothing but the center of an open sphere contained in A. Okay. Then the set of all interior points of A is nothing but interior A, and that interior A is always an open set. Clear? So we prove that A is open, then A is open, then interior A is A. We already proved that. Then if A is open, then interior A equals A. So here A is open if and only if interior A equals A. Okay, when interior A equals A, then clearly A is open. Why? Because interior A is an open set. So this is our conclusion. A is open if and only if interior A equals A. Why? We already know that interior A equals A. We know that interior A is always a part of A. This is immediate from its definition. Okay. When A is open, we know that interior A equals A. This is already proved here. How? Interior A is a part of A, that is 1. Then for the equality, we have to show that A is a part of interior A. Let X fall in interior A. Let X fall in A. Since A is open, there exists some R positive such that S Rx is a part of A. SRX is a part of A means X is an interior point of A. X is an interior point of A. That means X fall in where? X fall in interior A. But X fall in where? X fall in A. X fall in interior A. That means A is a part of interior A. So when A is open, interior A is a part of, when A is open, interior A equals A. Combines 1 and 2. A is open, interior A equals A. So A is open, interior A equals C. Okay. What about the reverse inclusion? How to prove this interior when next suppose that reversely we may suppose that interior A equals C. Next suppose that interior A equals C. Next suppose that interior A equals C. How to show this A is open? We know that interior A is open. We already proved that interior of A is we know that interior A is open. Since interior A is open but interior A equals A, that implies A is open. So finished. So this is our important result. A is open if and only if interior A equals E. Clear? We know that interior A is a part of A, and we already proved that when A is open, interior A equals A. Again we proved that interior A is an open set. So when A is open, interior A equals A is proved. Reversely, suppose that interior A equals A. Interior A equals C, then we know that interior A is open, then the equality shows that A is open. So that's an important result. A is open if and only if interior A equals E. This is a crucial point and it's an important theorem. Okay. Now, what is actually interior A? Interior A is the set of all interior points of it. Interior A is the set of all. Suppose this is A. This is A. And the interior of A is the set of all. There are number of interior points. So interior A will be the set of all interior points of it. Then actually this interior A is the largest open set that contained in it. Interior A is the largest open set that contained in A. So for let G is an open set. G is an open set such that G is a part of it. G is a part of it. Now we say that interior A is the largest open set contained in A. So here we have to show that G is a part of interior A. Since G is an open set such that G is a part of it. Now to prove G is, or if we prove G is a part of interior A, then we can conclude that interior A is the largest open set that contained in A. For any open G is any open set in A. If G is a part of interior A, then we say that then we can conclude that this interior A is the largest open set which contained in A. How? G is an open set. G is open. G is an open set. Means, so let X fall in G. Since G is an open set, there exists some R greater than 0 such that S Rx is a part of G. Why? Since G is open. G is open means there exists an open ball, open sphere such that then SRX is a part of G. But what is G? G is a part of E. So that means SRX is a part of E. SRX is a part of A since G is a part of A. SRX is a part of A means what is X? That means X be an interior point of A. X be an interior point of A. Okay, by definition. X be an interior point of A means X should fall in the X presence in interior of A. Why? Because interior A is nothing but the set of all interior points of A. So X fall in interior A. X is chosen from where? G. Same X fall in where? Interior A. That means G is a part of interior. So this shows that interior A is the largest open set that contained in E. So that is another important result. Okay. What about the interior point of closed open 1, 2? Interior point of closed open 1, 2. Come to the real line. 0, 1, 2. So it is closed open 1, 2. What is its interior point or interior of closed open 1? Suppose it is A. A equals to 1. Closed open 1. What is interior of A here? Interior of A is open interval 1 2. Why? Because interior of A is the largest open set contained in A. So, which is the largest open set contained in closed 1 2 is nothing but open interval 1 2. Similarly, open closed 1 2. Its interior is also open interval 1 2. Closed interval 1 2. Again its interior is open interval 1 2. Okay. Similarly, open interval 1 2 is its interior is also open interval 1 2 itself. What is interior of R? Interior of R. Set of reals. That's again R itself. Okay. And so. Now, that's an important result. If A and B are any two non-empty subset of X, A and B are, suppose A and B are any two non-empty subsets of X. They are the metric spaces with the usual metric D. Then, what is the metric D? Then interior A union interior B. Interior A union interior B is a part of interior A union. That's another result. Interior A union interior B is a part of interior A union. How to prove this one? Interior A union interior B is a part of interior A union B. So we know that interior A is a part of A. Okay. But similarly interior B. Interior B is also part of B. Then from here, what is interior A union interior B? Interior A union interior B is a part of A union. But we know that interior A is an open set. Interior B is an open set. Also we know that the union of two open set is open. Union of two open set is open means interior A union interior B is open. Interior A union interior B is open. But interior A union B, interior A union B is the largest open set that contained in. Interior A union B be the largest open set contained in A union B. Or interior A union B is the largest open set in A union B. So that means interior A union interior B is a part of interior A union. Okay. Interior A union B is the largest open set in A union B, that contained in A union B. So it is interior A union, in this sense interior A union interior B is a part of A union B, and the interior A union B be the largest open set that contained in A union B. Therefore interior A union interior B is a part of interior A union. Do you say that interior A union interior B equals interior A union B? What about the equality? The equality does not hold. Equality does not hold. Why? Because we can prove by an example. A equals closed open 1. A equals open closed. A equals open closed. And B equals closed open 2. So 1, 2, 3. A is open closed 1, 2. B is closed open 2. What is A union B? Here A union B equals open interval 1. A union B is open interval 1. So what is interior of A union B? Interior of A union B. Here interior of A union B equals open interval 1. Now what is interior A? Here interior A is open interval 1. And what is interior B? Interior B equals open interval 2. So clearly interior A union interior B, that is strictly differs from interior A union. Okay. So the equality does not hold. So this is an important result. If A union B are any two matrix spaces or any two S matrix spaces in X, then interior A union interior B is part of interior A union B. Clear? But what about the intersection? Interior A intersection interior B, which is equals interior A intersection B. This is another section. Interior A intersection interior B equals interior A intersection. How to prove this one? So for let X following interior A intersection B. X following interior A intersection B means, but what is interior A intersection B? Interior of any point, A intersection B is nothing but a set. Then interior of A is open. Clearly interior of A intersection B is also. Interior of A intersection B is open. Interior of A intersection B is, since S, interior of A intersection B is open, there exists some R positive such that SRX is a part of A intersection B. Okay, that means SRX is a part of A and SRX is a part of B. SRX is a part of A means X for an interior A by definition. X is an interior point of A means X for an interior. Similarly, X is an interior point of B, that means X for an interior B. So that means X for an interior A intersection interior B. Okay. So here let X is an interior A intersection B. Same X for an interior A intersection interior B. That means interior A intersection B is a part of interior A intersection B. That's the first observation. Again, for the reverse induction, suppose